Okay. So the arc length AB is 2 pi and the circle circumference is 6 pi. The closest distance to the chord of the chord AB to the center of the circle is going to be basically a line right from here, like that. So remember that the circumference of a circle equals 2 times pi times the radius. So if 6 pi equals 2 times pi times the radius, we can figure out from there that r equals 3. So the radius of the circle is 3. We can draw lines from the center of the circle to any point on the circle and have it equal the radius. So now this guy equals 3 and this guy equals 3. We now have a triangle. We also know that this arc length here, this 2 pi, is 1/3 of the entire circumference of the circle. If the arc length is 1/3 of the circle, the angle that generates it is also 1/3 of the circle. So since 360 is a full circle, 360 1/3 of that is going to be 120. This whole angle here is a 120-degree angle. If we draw this line, which is the shortest distance between the center and this chord AB, that will bisect that 120-degree angle into two 60-degree angles. So now this is 60 and this is 60. Because it's a perpendicular line, this is a 90-degree angle, which makes this a 30-degree angle, because all the angles have to add up to 180 in a triangle. We can then use that special property of triangles, where if you have a 30, 60, 90 triangle, the sides opposite those angles are respectively x times the square root of 3, and 2x. So whatever this is, the side opposite the 90-degree angle is twice that. We have the equivalent of 2x in this by having the radius of the circle. The angle opposite the 90 is 3. I'll put it in a different color. So the distance here, the side opposite the 30-degree angle, will just be half that, 3/2. And that is the distance from the chord AB to the center of the circle, the shortest distance. Answer choice B.